I'm Chris Pearce, a professor of computational mechanics in the James Watt School of Engineering. And I have been leading a research collaboration with the UK civil nuclear industry, in particular with EDF Energy, who operate all the UK's nuclear power plants. The UK's fleet of nuclear power plants, most of them are many decades old and probably operating beyond their existing design life. And as a result of that, they've started to observe cracks in the bricks that comprise the reactor core. And what EDF Energy were keen to understand is what were the causes of those cracks, how might they develop in the future, and ultimately, could they become a safety issue for the nuclear industry? Engineering software couldn't predict what they were observing. So what we did is we came in and brought some fresh ideas and fresh thinking to the problem. And we really tried to combine theoretical advances in mechanics and advanced scientific computing to come up with some really novel ideas as to how we can predict evolving cracks in the reactor core.
For nuclear industry, safety is a paramount. And then what we do, we try to predict the future because we understand the safety, and in nuclear industry understand the safety as the ability of predicting a future. If you know what will happen, you can prevent it. And our goal is to create the software which can predict that future. Hidden hero of this story is a software which is called MOFEM. It has own spirit, own character, own ways of doing stuff.
Nuclear power is a really important part of the UK's energy mix. Clearly, we have made huge strides in developing renewables, but what nuclear provides is what we call baseload electricity. So this is the proportion of our overall energy mix that is always on, is always available. And of course, it's also a low carbon electricity supply as well. So the impact of this work is allowing EDF Energy, as the operator of these nuclear power plants, to keep them operating. We can't simply replace a nuclear reactor or even part of a nuclear power plant. We can't suddenly overnight build a new one. So keeping the existing ones going is really important.
You want to make an impact on the real world around you. And this is the way how you make the imprint on the reality. You change something. One of the secondary effects of what we are doing, we're creating a generation of the computational scientists which are trained into us. They are learn how to professionally develop the software, how to apply the cutting edge solution techniques, and they move to the industry. They start to work in industry, they start to have a career, they start to have a good life. We have a feeling that this project will live now, and it will live beyond us.